Here is a question that sounds stupid and contains the entire history of the universe. Why is the night sky dark? Go ahead, laugh. I'll wait. I know what you're thinking. Feynman, that's the dumbest question I've ever heard. It's dark because it's night. The sun went down. I learned this when I was 4. Right. But here's the thing, that's not an answer. That's just describing what happened. I want to know why the sky between the stars is black. Why isn't it blazing with light? There are, and this is not an exaggeration, roughly 10 billion trillion stars in the observable universe. 10 billion trillion. That's a 1 followed by 22 zeros. Every single one of them is radiating light in all directions. Right now. Light is flying toward us from every corner of space, from stars so far away that by the time we see them they've been dead for millions of years. So I ask you again, and this time I want you to feel the weight of the question, why is the sky dark? Why isn't the night sky as bright as the surface of the sun? Why isn't it so bright that life on Earth is impossible? Why isn't every single point in the sky blazing? If you can answer that, really answer it, not just wave your hands, you've understood something about the age, the size, and the history of the entire cosmos. This problem has been sitting there, staring every human being in the face, every night, for all of recorded history. And the correct answer wasn't worked out until the 20th century. It required the Big Bang. It required understanding that the universe is expanding. It required knowing that light travels at a finite speed and that the universe is not infinitely old. All of that, from a dark sky. That's what I want to talk about today. Let's go. Let me show you exactly how strange this situation is. Because when you look at it carefully, the dark sky isn't just surprising, it's a logical scandal. Step outside on a clear night, away from city lights. Look up. What do you see? A black sky, a few thousand stars visible to the naked eye, and the faint smear of the Milky Way if you're lucky. Mostly black. Occasionally bright. That's what everybody sees. That's what every human who has ever lived has seen. Now, pick any direction. Point your finger. You're pointing into space. You go out along that line, out past the moon, past Mars, out of the solar system, through the Milky Way, past the Andromeda Galaxy, out into intergalactic space. Keep going. What eventually stops your line of sight? In a universe filled with stars, in an infinite universe filled with stars, the answer should be a star. Always. Every single direction should end on a star. The blinding sky prediction. Here is what the mathematics of an infinite, static, eternal universe filled with stars predicts. The entire sky should glow uniformly, as bright as the surface of the sun. Every point, not just the bright dots, the whole background. Brilliant, blazing, wall-to-wall light. The temperature at the surface of the sun is about 6,000 degrees. If the sky were as predicted, if Olbers' nightmare came true, that is the ambient temperature of the universe. Everything on Earth would be vaporized. There would be no oceans, no atmosphere, no life. No one to look up and notice how bright it is. And yet, dark sky. Cool planet. You, watching this video. Something is catastrophically wrong with that prediction, which means something is wrong with our assumptions about the universe. And I want to go after those assumptions, one by one, like a detective. Because that's really what physics is. You notice something that doesn't fit, and you go looking for the liar in the room. This puzzle even has a name. It's called Olbers Paradox, named after a German astronomer, Heinrich Wilhelm Olbers, who stated it clearly in 1823. But honestly, Kepler worried about it, Halley wrote about it. This problem kept nagging at anyone willing to stare at the sky and think seriously. It's one of those questions that refuses to go away until you answer it right. So, now we know the observation. Now we know the scandal. Let me show you the geometry that makes it so sharp, and then I'll show you exactly how nature resolves it. Let me do a little thought experiment. This is the kind of thing I like to do on a blackboard, so imagine I've got a piece of chalk in my hand. Imagine the universe is infinite and stars are spread through it more or less uniformly, same average density everywhere. Now, I'm going to divide the universe into shells around me, like the layers of an onion. The first shell is from distance r to distance r plus a little bit. The second shell is farther out. And so on, forever. Here's the key calculation. How much light does each shell send to me? Two things happen as I go to farther shells. 1. Each individual star is farther away, so it appears dimmer. Specifically, its apparent brightness drops as 1 over distance squared. 2. But each shell is bigger. It has more volume, so it contains more stars, proportional to distance squared. These two effects cancel. Exactly. Each shell contributes the same total amount of light to my eye, regardless of how far away it is. So if there are infinitely many shells, the total light reaching me is infinite. That's the paradox in its mathematical form. Almost elegant, isn't it? The geometry of three-dimensional space is working against you. As you go farther out, stars get dimmer, but there are more of them by exactly the compensating factor. Nature seems to have set a trap. Let me say this another way, because I want it to really land. Imagine standing in a forest that goes on forever in all directions, with trees of uniform density. Now look straight ahead. Eventually, if the forest is infinite, your line of sight must hit a tree. Always. In every direction. So wherever you look, you see tree bark. The entire visual field is tree. This is exactly the argument for the night sky. In an infinite, static, uniform universe populated with stars, every line of sight must eventually end on the surface of a star. So the entire sky should be as bright as the surface of a star. The sun's surface is roughly 6,000 degrees, blazing, vaporizing, wall-to-wall fire. And yet, dark sky. Cool night. A kid in Queens lying on his back and staring up at nothing. So something is wrong with the assumptions. Now, at this point, people make two classic mistakes in trying to fix this. I've seen both of them. Let me take them apart one by one, because understanding the wrong answers is half of understanding the right one. Olbers himself proposed a solution. He said, maybe the universe is full of dust and gas, interstellar matter, that absorbs the light from distant stars before it reaches us. The farther stars are simply blocked. Problem solved. Not quite, friend. Here's the problem with that. If you shine enough light on anything for long enough, dust, gas, rocks, whatever, it heats up. It reaches thermal equilibrium. In an infinite static universe that's been going on forever, the dust would have absorbed so much starlight that it would have heated up to the same temperature as the stars themselves. And then it would glow just as brightly. So you haven't solved anything. You've just replaced one blinding source with another. This is a subtlety that trips people up. Opacity alone doesn't fix the paradox. You need something more fundamental. The second mistake people make is thinking the universe's expansion solves it entirely through something called redshift. You've probably heard of the Doppler effect. When a source of sound moves away from you, the pitch drops. Same thing with light. When a light source moves away from you, the light gets stretched to longer wavelengths. It gets redshifted. Since distant galaxies are moving away from us, the universe is expanding, their light gets redshifted. Some of it shifts right out of the visible spectrum. Now, this is real. This does contribute to the darkness of the night sky. But, and this is important, it's not the main answer. The redshift effect reduces the energy of incoming light, yes. But even accounting for that, the universe doesn't become dark enough through expansion alone. So what is the real answer? Let me tell you. And I think when you hear it, you'll feel what I feel every time I come back to this problem, a kind of quiet shock at how deep the implication goes. The real answer is this. The universe is not infinitely old. That's it. That's the key. The universe had a beginning that happened a finite time ago. This is the Big Bang picture, which was being assembled and confirmed during my own lifetime. George Gamow, a wonderful, brilliant, funny man, was one of the people who worked out the physics of the early universe, and I knew him. Here's what finite age means for light. Light travels at a fixed, finite speed, roughly 300,000 kilometers per second. That's fast. But the universe is enormous. Light from the Andromeda galaxy, the nearest big galaxy to ours, takes about 2 million years to reach us. So when I look at Andromeda, I'm seeing it as it was 2 million years ago. I'm not seeing it as it is now. I'm looking into the past. Imagine standing in a forest that goes on forever in all directions, with trees of uniform density. Now look straight ahead. Eventually, if the forest is infinite, your line of sight must hit a tree. Always. In every direction. So wherever you look, you see tree bark. The entire visual field is tree. This is exactly the argument for the night sky. In an infinite, static, uniform universe populated with stars, every line of sight must eventually end on the surface of a star. So the entire sky should be as bright as the surface of a star. The sun's surface is roughly 6,000 degrees, blazing, vaporizing, wall-to-wall fire. And yet, dark sky. Cool night. A kid in Queens lying on his back and staring up at nothing. So something is wrong with the assumptions. Now, at this point, people make two classic mistakes in trying to fix this. I've seen both of them. Let me take them apart one by one, because understanding the wrong answers is half of understanding the right one. Olbers himself proposed a solution. He said, maybe the universe is full of dust and gas, interstellar matter, that absorbs the light from distant stars before it reaches us. The farther stars are simply blocked. Problem solved. Not quite, friend. Beat. Here's the problem with that. If you shine enough light on anything for long enough, dust, gas, rocks, whatever, it heats up. It reaches thermal equilibrium. In an infinite static universe that's been going on forever, the dust would have absorbed so much starlight that it would have heated up to the same temperature as the stars themselves. And then it would glow just as brightly. So you haven't solved anything. You've just replaced one blinding source with another. The universe is roughly 14 billion years old. The observable universe has a radius of about 46 billion light years. You might ask, if the universe is 14 billion years old, how can anything be 46 billion light years away? Shouldn't the farthest we can see be 14 billion light years? Good instinct. The catch is that the universe has been expanding all the while light was traveling. Space itself was stretching. So objects that emitted light toward us long ago have since moved much farther away, even as their light was en route. The geometry of an expanding universe is richer than flat space geometry. But the principle is the same. Finite age means finite observable volume means finite total starlight. And there's one more piece. Stars themselves are not ancient. For the first few 100 million years after the Big Bang, there were no stars at all, just hot plasma, then cooling hydrogen gas, then the slow gravitational collapse that eventually ignited the first generation of stars. So even the early universe was dark. The past is not uniformly lit. It has a structure. Put it all together. Finite age, finite stellar history. Cosmic expansion dimming distant light. The blazing infinite sky of Olbers' nightmare dissolves into exactly what we observe, a dark canopy punctuated by brilliant nearby stars, with the smear of our own galaxy arcing overhead. When you look at the dark sky between the stars, you are not seeing emptiness. You are seeing the edge of time. That is not poetry. That is physics. I want to sit with this for a minute, because I think it's one of the most remarkable things in all of science. We just established, from a simple observation that every human who has ever lived has made, that the universe must be finite in age. We didn't need a particle accelerator. We didn't need an elaborate experiment in a laboratory. We needed a dark night and the willingness to ask why. To push past the easy dismissal. To refuse to accept its night as an answer. That's exactly what we did at the top of this video. We took the dark sky seriously as a clue. And it paid off. And you know what's interesting? Edgar Allan Poe, yes, the writer, the one who wrote the creepy stories, he actually got pretty close to the right answer in a long prose poem called Eureka, written in 1848. He suggested that the reason the sky is dark is that the light from the most distant stars simply hasn't had time to reach us. He was thinking about it correctly, intuitively, decades before it was stated rigorously by physicists. I have a certain affection for that. It shows that good thinking isn't the exclusive property of people with university positions and laboratory budgets. Now notice what happened in this problem. The paradox arose from a set of seemingly reasonable assumptions: infinite universe, uniform density of stars, static universe, infinite time. Each seemed plausible. And yet they led to an absurdity: a sky as bright as a stellar surface. A contradiction with what we actually see when we go outside at night. In science, when theory contradicts observation, you don't throw out the observation. You go after the assumptions. That's what happened here. And when the wrong assumptions were replaced with better ones, finite age, expanding universe, stars forming late in cosmic history, the paradox dissolved, and a whole new picture of the cosmos emerged. Every time you look at a star, you're looking at the past. The star you see isn't the star as it is now, it's the star as it was when the light left it. For nearby stars, that's just a few years. For distant galaxies, it's billions of years. We are, every night, looking out into a museum of cosmic history. The universe itself is the exhibit. And the dark parts, the blackness between the stars, those are the places whose light hasn't arrived. The parts of the universe so far away, or so early in its history, that their signals are still in transit. The dark sky is not an absence of stars, it's an absence of time. There is a sphere around each of us, centered at our position, beyond which we simply cannot see. Not because anything is blocking it, but because time has not permitted the information to travel. We are embedded in a finite bubble of knowable history, floating in something larger, something we can reason about but never directly observe. And the boundary of that bubble, that's what you're looking at when you look at the dark night sky. Every time. Every night. Let me bring this home. All the way back to where we started, that dangerous question. We opened with a provocation, a question that sounds stupid and contains the entire history of the universe. And then we went and proved it. We showed that the dark night sky isn't a trivial observation. It's a message. The cosmos is telling you, every single night, that it had a beginning. Here's the chain of logic, laid out clean. If the universe were infinite, static, uniformly filled with stars, and infinitely old, the sky would not be dark. Every line of sight would end on a stellar surface. The night sky would blaze at 6,000 degrees. Nothing survives. No one asks questions. Since it doesn't blaze, since it's dark, at least one assumption must be wrong. The crucial one is age. The universe is approximately 14 billion years old. Light from beyond the observable horizon hasn't reached us. The sum of all incoming starlight is finite and small. The sky is dark. Moreover, stars formed only after the first few 100 million years, so the early universe contributed no stellar light even in principle. And cosmic expansion dims and stretches the light from distant sources, adding to the darkness. 3 effects. 1 answer. Dark sky. Now, the method. Because I think the method is more important than any single result. The method is, take what you actually observe seriously. Don't dismiss it. Don't say, well, that's just because it's night. If something seems trivial but turns out to be in tension with a theoretical prediction, that tension is a signal. Chase it. Because at the end of that chase, you very often find something wonderful about the structure of nature. The dark night sky told us the universe is young. That observation has been available to every human being for all of human history, but it took centuries to ask it right, and then to answer it honestly, without flinching from where the logic led. Closing analogy, the question as a key. A question is like a key. Most questions look small, they don't look like they could open anything important. Why is the sky dark? Sounds like a question for children. But you fit that key into the lock of careful reasoning, and you turn it, and a great door swings open. On the other side, the finite age of the universe, the Big Bang, the expansion of space, the whole grand history of everything. You know, I've spent my career worrying about quantum electrodynamics, the interaction of light and matter at the smallest possible scale. Photons and electrons, probability amplitudes, all of that. And I'll tell you something, the pleasure I get from that work is the same pleasure I get from this problem. The same pleasure I got lying on my back in Far Rockaway as a kid, staring up. It's the pleasure of noticing that something you thought was obvious actually isn't. That the world is stranger and richer than it first appears. That reality has layers, and every layer you peel back reveals another, more interesting one beneath. The night sky is dark. Now you know why. And now you know that the knowing of it took centuries of human effort, and contains in it the entire story of the observable universe. That's not bad for looking up. Thank you.